Hello, everybody. Welcome back. Got a good crowd today, it seems like. That's good. That's always good. Well, say hi if you're here, and then we'll get to reviewing for the test tomorrow. Navik, welcome. Hope you liked that calculus lesson we went over in linear algebra today. Hello, Jax. All right, we'll get started in about a minute. Hopefully some people trickle in by the time class starts. Wouldn't want to miss a review day. That is for sure. All right, well, it's 10 o'clock, so I guess the about a minute was like 20 seconds. Almost, I forgot to say that I love your live streams. Thanks, Navik. All right, well, if anybody has their coffee or, hello, Jared, coffee or water or tea, apple juice, I don't know. Feel free to join me in this simultaneous sip. Good morning, Jonathan. Yeah, that's the last simultaneous sip we'll have before the exam, right? Because we're not going to have the live stream tomorrow. Hello, Max. I guess if you really are desperate for a simultaneous sip, you probably have a mirror at your house. So you can just take a sip in front of a mirror. All right. A lot of people joining in today. That's excellent. So it's going to be just like what we did last night. I don't know if you were all there. We just cranked through some of the problems that I provided. So we're going to do the same kind of idea today. So if anybody, just put in the chat what kind of question you want to go for. I don't know if you saw this, but my stream from yesterday, the office hours, has like 250 views, which is a lot for me. I know that's not a lot for like a regular YouTube video, but it's a lot for me. All right, I need some questions. I can't just stand up here and do small talk with a screen the whole time. Optimization, sure. Do you have a specific one, Jax? Oh, Inman said use up first. All right, well, either of you, give me a specific number. Number four. All right, two people said 4. Let's start with that. Inman, find a good use of question. They're towards the end of the review packet are the ones that require use of. Hopefully some of those viewers turn into subscribers. Yeah, I'm with you 100%. All right, number 4. All right, I'm not going to write this whole thing down because it's a paragraph, but I'll read it and we'll draw along. A farmer wants to fence in a rectangular plot of land adjacent to the north wall of his barn. Okay, so there's, all right, this is a bad drawing. All right, so here's his land, and then here's the barn. Barn. No fencing is needed along the barn. All right, so we don't need any fencing here. And fencing on the west side is shared with the neighbor. West over here. So here's a neighbor who splits the cost. If fencing costs $20 per foot, and he's not willing to spend any more than $5,000, find the dimensions that will enclose the most area. Okay, so we need some sort of constraint function, and we need a function that we want to maximize. And then we'll get to number 23, Eamon. So let's start labeling these sides. We don't have to worry about the barn. Maybe we could call this W, and we could call this L, and we could call this W, because it's a rectangle. So what's the cost of each of these regions? This region costs $20 This region costs $20 or this segment of the fence. And this segment over here costs only $10 right? Because it's being shared with the neighbor. Are we happy with what we've drawn so far? So let's add up these costs. So 30W plus 20L. And we want to use, right? We don't want to keep money in our pocket. We want to use all $5,000. All right, so this is our cost function. The cost of a fence, we want to add up to 5,000. All right, where do we go from here? What's the area? Yeah, X, Y, I used L and W, so length times width. But we don't know how to optimize a function of two variables, right? We only know how to do it when there's only one variable. So how do we eliminate one of the variables? Substitution, yeah. So let's solve for one of the variables up here, and then we'll plug it in. So if we solve for L, we get L is equal to 5,000 minus 30W over 20. So L is equal to 250 minus 1.5 W. All right, here, now we want to take the derivative of this function. It's probably easier for us first to multiply the W in, so we don't have to do the product rule. So we'll take the derivative. I was kind of in the integral mindset. I almost wrote out what the integral was. All right, we take the derivative. So that's 250. Yeah, make sure on the test tomorrow when you have a question that requires you to take a derivative, you take a derivative. And when you require an integral, you do an integral. I know it's you get in one mindset and you kind of forget how to do the other one, but both skills are obviously important. So what do we do with this? Yeah, set it equal to 0, right? Because what we're trying to do is trying to find a max or a min. Well, we're trying to find a maximum in this case. So remember, maximums occur when the derivative is 0 or undefined. That's why we're setting it equal to 0. And so we get W is equal to 250 over 3. And then to get L, you just plug that 250 over 3 into W here to get L. So L equals 250 minus 1.5, 250 over 3, which works out to be 250 over 2, which is 125. All right, and so what was the question actually asking? Find the dimensions. So we did that. The width would be 250 over 3. The length would be 250 over 2. If it asked us to find the area, to maximize the amount of area, you would just multiply these numbers together. But it didn't ask us that. On the test, what we need to verify that the answer is a maximum via the second derivative test. You know, that's a good way to check your answer, Jax. But for the purposes of time, your answer will likely be, well, no, your answer will be, the answer you get will be like what you're looking for. So it's fine to just to leave it like this. Right, it wouldn't take too long to check that it's a maximum, right? You take the derivative of this, you get -3, so it's always, the derivative is always negative. So it's always concave down. All right, so what was the other question that was asked? 23. So this is number 4, by the way. So we want to evaluate the integral of x squared secant squared of x to the third dx. So does anybody have any ideas of how they might go about solving this? Yeah, good. So what Jared said is some important insight into this question. Secant squared goes to tan x, right? The integral of secant squared x is tangent x. That's one of our identities. So we could probably use that. Navik says u sub. Okay, so let's combine those two thoughts. Nicole suggests u equals x to the third, so du equals 3x squared dx. Yeah, let's try that. See where it leads us. We have an x squared dx. So let's solve for x squared dx. And so now let's sub everything in. So x squared dx becomes, well, 1/3 du. And secant squared x to the third becomes secant squared u. Right, now we'll use the fact or the identity that Jared stated a few comments ago. It says secant squared, the integral of secant squared of u is tangent of u. Since we have an indefinite integral, we got to remember it's a full family of functions that satisfy this. So it's plus c. All right, where do we go from here? Yeah. So we started with x's, so we should end with x. All right, and then the next question is, how do we check our answer? How do you check your answer? Just if you have extra time tomorrow and you want to make sure you did this correctly, how do you check your answer? Yeah, you would just take the derivative, right? So if we took the derivative of this function, we should get back x squared secant squared of x to the third, right? And we do. The derivative of tangent is secant squared. The inside stays the same, but then we multiply by the derivative of x to the third. So the 3 would cancel and we'd be left with an x squared. So yeah, you could check that the derivative of this function is x squared secant squared x to the third. All right, so Yeah, ask any other questions you have. Whoa. Will and Jax both said 12 simultaneously. So let's take a look at it. All right, evaluate this integral by interpreting it in terms of areas. We don't know how to evaluate the integral any other way. So if there's an integral that we don't know how to integrate, and I would tell you to use areas, but that's our only tool at this point. Okay, so we want to do the integral from -5 to 5 of x minus 25 minus x squared. And the hint, or the way they want us to evaluate it, is using areas. Well, we don't know what this graph looks like. And we definitely don't know, like, symmetry check. That's a good idea, right? It does seem like a candidate for a symmetry check. But it's tough. We have an odd function and an even function. So odd minus even doesn't tell us anything. Unfortunately, we don't know how to graph either. We don't know how to graph these when they're combined. But what we could do is express it as the integral from -5 to 5 of x dx minus the integral from -5 to 5 of the square root of 25 minus x squared dx. Why could you not use u sub here? Is it because the two components are separated by yeah, exactly. They're separated by a minus. If it was by times, then u sub would work. Yeah, so the techniques used to evaluate this integral involve something called trig sub. Believe it or not, switching our variables to a trig function. It's magic. It's not magic, but it makes the question easier. Yeah, that's Calc 2 stuff also. Some of the best stuff. Oh boy, trig sub gives me nightmares. No, that's. I mean, you can see it. My rosy cheeks smiling right now. How much just thinking of trig sub. Whatever. Okay. So we want to evaluate these integrals. Now, what Jared said, testing a symmetry check, we could definitely use symmetry for this one, right? F of x equals x is an odd function. So this integral, and we could also just evaluate this integral. This integral is 0. Right? There's 100 ways we could check that. We could draw out the picture, show the area above the curve on the right is the same as the area below the curve on the left. We could actually just take the antiderivative and plug in the endpoints. So we're left with this part. What does the curve y equals the square root of 25 minus x squared look like? Yeah, it's a semicircle. With radius 5. Okay, and we want to find the area under the semicircle from -5 to 5. So we want to find the area of this region. And then we'll just make it negative at the end because we had a negative out here. So what's the area of this region? What is the area of half of a circle with radius 5? All right, this is not a trick question here. $34.27. Maybe? Seems like, yeah, let's leave it in terms of pi. Is that, Jonathan, is that what you got when you plugged in 25 pi over 2? But yeah, so the full circle with radius 5 would have area 25 pi. So half the circle is 25 pi over 2. So our integral is negative 25 pi over 2. Yeah, so I think it would be, leave it in terms of pi. WebAssign might like it with decimals for whatever reason, but it's definitely cleaner when you have it in terms of pi. Yeah, and so the negative comes from the fact we had a negative on the outside. If we had like a 4 out here, then we multiply that number by 4. So if there's some scalar out here that wasn't just -1, you would just take our area and multiply it by that scalar. So Jax asks if the bounds were different, if they were from 0 to 5. Yeah, so then we would only look at a quarter of the circle. And so it'd be 25. Yes. So we want to evaluate the integral from 0 to 4 of x over the square root of 1 plus 2x dx. So what are we thinking? Does anybody have any thoughts on this? Greg suggests u sub. That's a good idea. What would our substitution be? Yeah, let's try u equals 1 plus 2x. See where that takes us. So du would be 2 dx. Dx would be du over 2. We're still left with an x. Right? This part becomes u, that becomes du over 2. What about this x? Solve for x in terms of u. Yeah, so x is equal to u minus 1 over 2. Okay, let's just make sure we got everything. X, we're good with. Dx, we're good with. This bottom part, we're good with. The bounds. How do we figure out the bounds? Right, these bounds are in terms of x. We want them to be in terms of u. How do we figure that out? Plug bounds in terms of u. Yeah, so we'll plug in the bounds into our u function. So u of 0 is equal to 1, and u of 4 is equal to 9. Okay, so our integral is the integral from 1 to 9. All right, we have a 1/2 here. We have another 1/2 here. So that's a 1/4. U minus 1 over the square root of u du. Did this actually get any easier is the question. I mean, the answer is yes, but where do we go from here? What do we do to this expression to make it easier to work with? Separate each component. Yeah. So this is u over root 2 minus 1 over root 2 du. And then we can simplify it. U to the 1 over u to the 1/2 is u to the 1/2. And then this is minus u to the negative 1/2. Right, this is easier to work with. Where did the 1/4 come from? Well, let's see. Here we had a 1/2 from x. We also had a 1/2 from dx. So both of them factor out as a 1/4. So now we could just plug in the endpoints and see what we get. 9 to the 3/2 is 27. This would be a fine way to leave your answer on the test, by the way. So this is 18 minus 6 is 12 minus negative 4/3, so plus 4/3. Whatever this works out to be. So I think my answer key is off by a factor of 2. Is that true? Is that what the issue was? So my answer key says 6 2/3. I like our answer here, 3 1/3. How did I find du? I took the derivative of this. So 1 plus 2x. The derivative is 2 dx. Yeah, I think my answer key lost a 1/2 in the early steps. So if that's where the confusion was, I apologize. Are we happy with this answer? Do people have any thoughts? If you have no thoughts, and does anybody want to say what their next question is? How did you get u to the 3rd over 2? Here, I increase the power by 1 and divide by the new power. So 1/2 plus 1 is 3/2. Right? Increase the power by 1, that gives us 3/2. Increase the power by 1, that gives us 1/2. Ten. Sure. All right, estimate the area under the graph of f of x equals 1 plus x squared, -1 to 2, using, I have in mind, I had the word 4 and I crossed it out to 3, so I'm not sure which version you guys have. 3 rectangles and left endpoints, and then repeat the process for right endpoints, and then repeat it again for midpoints. Okay, well, we could talk through how to do this, but I don't have a calculator, so we won't be able to actually get the actual numbers. But basically what we want to do is figure out what our sample points are. So we want to break it up into 3 rectangles. Our sample points, because we start with left endpoints, would be here, here, and there. And delta x would be 2 minus -1 over 3. So the area under the curve is approximately equal to this sum. I guess we could do this without a calculator. Two plus 1 plus 2 is 5. All right, but then the question says do it again with right endpoints. So the only thing would change is where our sample points come from. So our sample points would be 0, 1, and 2. And plug it into this. Or if it was midpoints, I guess we could, with midpoints, it'd be -0.5, 0.5, and 1.5. So this is where a calculator would be handy. Did that answer your question? Yeah, so for that question, the important part was finding the sample points, and then it's just a matter of plugging it into your function. On the test, do we have to put integral from -1 to 2 of? So you do approximate. Like, so this is an estimation. So you could either write the integral. You could either write a is approximately equal to that, or you could write that integral is approximately. But you should do approximate, not equals. Navik says, question 25, MATLAB gives 10/3. Oh, good. So yeah, we made a mistake in my answer key. I just lost a 1/2, and I see it in the answer key. It's from the first step to the second step. We lost a 1/2. But yeah, so we'll just either write the area is approximately equal to, or the integral is approximately equal to. Either one of those is fine. But the key is it's an approximation. It is not. This is not an equality. Right? If we took the limit as the number of regions goes to infinity, then it becomes an equality. We could probably do one last quick one if anybody has another one. And I also have office hours today, so if people want to come to that, I think those happen right after class. Are there any other questions? The test is not on YouTube, no. Are we going to have the same amount of time to upload the exam? Yeah, it'll be the same as last time. So I'll give you the test will be made public at 9:50, and then you'll have until 11. I have learned how to not have it lock at 11, so I won't do that. But it will put up a big old stamp that says late on it if it's after 11 o'clock. So if I were you, I would take from 9:50 to 10:50. 9:50 to 10:50 to work on the exam. It's a 50-minute exam, so having an hour is plenty. And then the last 10 minutes, figure out how to post it to Canvas. Navik, no, it's in Zoom. So unfortunately, only students that are currently enrolled in my class will be able to go to the office hours today. Spend time on your physics exam. This test should be shorter. The amount of time it takes to take this test will be less than the previous test. Test 2 is always the longest. So it stinks that test 2 had to be over the internet. How do we know when we can use sub and you can't? It's like art, you got to see it. There's not like a set way of telling, unfortunately. My first thing you should do is try to solve the problem without use substitution. And if you can't, then try use substitution. Yeah, it stinks that it's not like something, let me just test a couple of things and does use sub, it satisfies these conditions, so we use use sub, but that's not the case. Yeah, so it does take a little bit of creativity or some guessing and checking to see if we could do use sub. All right, well, if there's no last minute questions, feel free to come to office hours in 10 minutes. Make sure to hit the like button before you get out of here. 5 likes, that is not acceptable for the day. I'm kidding. But the day before a test, you know what I'm saying? I would have expected 100 likes at this point, but I guess I'm out of it a little bit. Yeah, so take a look at these questions that I posted. Also, those YouTube videos I sent you. Those are some good questions. The book has a bunch of practice problems with use substitution. You should look at those. Also, if you want somebody to check if you're right or not, there's WebAssign for 4.5 that you could do as practice for use substitution. All right, well, I'm going to end this. Navik says he hopes everyone has a good afternoon. I will see some of you at office hours potentially. If not, good luck studying. Bye-bye.